This is going to be the entire lesson from our fundamental counting principle lesson. So in case you missed it, this is a good chance for you to learn the material, or in case you want to just review it, this is the video that'll cover the entire lesson for it. The goal of today's lesson, we're going to working on using the fundamental counting principle to calculate different combinations that we can have. If you're trying to determine how many outfits you can wear, you'll use the fundamental counting principle. Different ways that you can arrange, like flags, or different ways that you can arrange people, stuff like that, is the fundamental counting principle. So Andy has 3 paintings, and he wants to arrange them on the wall in his office. How many possible ways can he arrange them? And we can go through and list each one of them. Let's say one is a rectangle, one is a diamond, and the other one is an oval. If we wanted to, we could just draw them all out, arrange them all, and see how many different arrangements we can make up. If we did that, it'd take a little bit of time. We'd find out that there are 6 possible outcomes. But there's got to be an easier way to determine this. And so we're going to go through one thing right now called a tree diagram. And so if we use a tree diagram to determine our different outcomes, this is very useful when we get to later on to probability. If we have a tree diagram, what we need to think about here are 3 different shapes that we can use. And the first position can be any one of those, a rectangle, a diamond, or an oval. Let's just choose one and start with that. If the first one is a rectangle, then what are my options for my second position? Well, let's see. If I use the rectangle first, that means I'm only left with either the diamond or the oval, one of the two. So the diamond or the oval. And then if I use the rectangle first, then the diamond, I only have one option. The last one has to be in third position is the oval. Or if I went rectangle, then oval, my third position would be a diamond. That would give me 2 different possible outcomes right here. Either I could do a rectangle, a diamond, then an oval, or a rectangle, an oval, then a diamond. Any one of those. And this really helps for visual learners to draw this tree diagram. This will work every time. We'll learn a little bit of a shortcut for most of it later. But there are still instances in which this would be the easiest way to calculate the probability, is just to do a tree diagram. So you want to get in the habit of just at least knowing what it is and trying it once or twice. Then you can determine if it'll be the easiest route for your particular problem. So this is if we did the rectangle first. Well, what happens if we did the diamond first? So if we choose to do the diamond first, that means the next one will either be a rectangle or an oval, one of the two. And if it goes diamond, rectangle, then the next one has to be an oval. And if it went diamond, oval, rectangle, then the next one have to be a rectangle. So we have an additional 2 different outcomes that we can have. And the final one is our oval. If we have an oval, then we can either have a rectangle or a diamond next. And we're going to follow that same pattern. What we'll realize here, if we use this tree diagram, is that we have 6 different options for ways that Andy can hang those pictures. And the biggest thing is just really seeing it for the first time and then trying it. So let's try one right now. Here is our scenario. What I want you to do is I want you to read this one, then I want you to actually draw the tree diagram on it. Go ahead and push pause on the video now. Okay, so hopefully you can check your answers here. Should have ended up with 9 different possibilities. Here are your tree diagrams. You can either do a small, medium, or a large. And we have 3 different flavors or fruits that we can mix in with them. So that would be our tree diagram. Now we're going to move on a little bit to flipping a coin and rolling a die. Well, if we flip a coin, how many different possible outcomes can we have? A coin, you're going to flip it and you'll either have a heads or a tails, one of the two. What about if you roll a die? Now, we're assuming that it's a traditional die, that is a 6-sided die. They do make some that are like 12-sided or 18-sided or whatever else, but a 6-sided die, if it doesn't specify, then it will be a 6-sided die that we're referring to. So a 6-sided die has 6 different possible outcomes. You can have a 1, 2, 3, 4, 5, or 6, any of those. Those are the total number of possibilities that we can have. So what is the number of outcomes that we can have if we are flipping a coin and rolling a die? So now we've got our die here. For flipping a coin, we have heads or tails. For each one here, we can have a heads or tails combination that we can use. So we want to start looking at these. There is a relationship that goes together here. This is what we call the fundamental counting principle. Okay, we've got 2 options for heads, and we've got 6 options for die. Now, if we were to add all these up, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 different possibilities. So here really is the fundamental counting principle. Basically what we're going to be doing with it is just multiplying all the different options that we have. So if we want to think of flipping a coin and rolling a die, if we flip a coin, that's going to have 2 options. Then if we roll a die, that's going to have 6 different outcomes. Now what we're going to do is multiply these 2 together, and that would give us 12 total outcomes. So that's our shortcut, okay? The fundamental counting principle is the shortcut. Basically what we're going to be doing is just multiplying the different possibilities of each one, and that'll give us the total number of different combinations we can have. This would be the same thing if we went and listed each one of them out. If we did the tree diagram, we'd get the same answer, but it's a lot easier if we can just multiply these 2 together. Alright, now let's look at this. If I have 2 dice, one of them is red and one of them is green. If I roll the red die, we need to think about this individually. If I roll the red die, how many different outcomes do I have? And again, it's not specified, so it's assumed that this one is a 6-sided die. So with the red die, I have 6 different outcomes possible. Now, if I have 6 for the red die, I'm going to have 6 for the green die as well. So now what I'm going to do is multiply those 2 together. So I've got 6 for the red die, 6 for the green die. Together we're going to have 36 different possible outcomes with these 2 dice that I'm going to roll. Now I'd like you to try this one. And just push pause right now. Whenever you're done with it, then you can push play again and we'll continue on with the lesson. Okay, hopefully you came up with this as your outcome. Now this one we added just a little bit of variation to it. I said for number 2, if I roll a number under 3, so how many numbers are under 3? That can either be a 1 or a 2. We're not including 3 because 3 is not under 3. 3 is equal to 3. So, okay, with this one, I'd like you to go ahead and try this one. Push pause now, and then whenever you've completed the problem, then you can come back and check your answer. Hopefully you found out that there were a total of 96 different combinations for the Sundays and 18 different combinations for the outfits that you can wear. Now we're asked, how many different ways can 5 runners finish a race? So we've got 5 in here. They're going to finish anywhere from 1st to 5th somewhere. Okay, 1st place all the way through 5th place. Now we need to look at this. How many different runners, how many different ways can these 5 different runners finish in 1st place? How many different variations, how many different combinations can you think of? And we've got 5 runners, so obviously we can have 5 different possible ways that they can finish first. Now in 2nd place, we don't have 5 because one of them is already taken up in 1st place. So we've already got one person in 1st place. After we have that, now we only have 4 other runners left to choose from. So in 2nd place, we actually only have 4 possible runners to go into 2nd place. And then we're going to follow this trend on down. In 3rd place, we're not going to have 5 either. We already have 1 here and 1 here. That only leaves 3 left, 3 more runners left to choose from. So we have 3 possible different ways we can have a 3rd place finisher, 2 possible 4th, and 1 possible 5th place. There's only 1 person left. So now what we do with using the fundamental counting principle, it basically says to go in here and just multiply all these together. So we're going to go through and multiply this whole thing together. And hopefully you remember that that is a 5 factorial. And 5 factorial is just 5 times 4 times 3 times 2 times 1. And you can just plug that into your calculator if you want. That'll be fine. But 5 factorial, just plug that in your calculator and you'll end up being 120 different ways that these 5 runners can finish this race. Alright, now we're going to get some more practice right now. So here's the next 2 problems. Go ahead and work these out. Push pause now and then you can come back to it whenever you've answered it. Hopefully you found out that this one was 720 different ways to place a book on the shelf, because in that 1st position we have 6 different possibilities. In the 2nd position we only have 5 because 1 was taken already with the first in the 1st position. So hopefully you're kind of starting to get the feel for this a little bit. Let's go on now to the next one. Go ahead and try this one and push pause now and then you can come back to it. This one we have, a lot of times it's very confusing, so I want to go through this one for you in just a second here. different ways that you can answer a multiple choice test. It has 4 questions with 4 choices, so 4 answers, A, B, C, or D. So question number 1 has 4 different options that you can choose from. Question number 2 has 4 different options you can choose from. Question number 3 has 4 different options, and question number 4 has 4 different options as well. Using the fundamental counting principle, all we're going to do is multiply all of those together. So if you're one that got 16 on this one, you've got to think about it just a little bit further here. 16, if I only had 2 questions, that would be the number of different outcomes that I can have. But with 4 different questions, I'm going to take the total number of possible answers on each one and then just multiply all those together. And that will give me my answer. All right, now I want you to go ahead and try this one now. Go ahead and push pause right now and you can try this. Here should have been your answer. This one was just a little bit different. You've got to think about how many digits there are. If you look at your calculator right now, you'll notice that there are 9 digits, 0 through 9. Excuse me, 10 digits. There are 0 through 9. So there are 10 different digits there, and the alphabet has 26 letters. Now, we are assuming that these combinations are not case sensitive. In other words, they can either be an uppercase or a lowercase. It doesn't matter whether it's uppercase B or lowercase b, it's all a B. So otherwise it'd be 52 different options. But in this one, we're just assuming that it's a letter is a letter, and that's it. It doesn't matter whether it's uppercase or lowercase. Okay, last one here. Go ahead and try these 2, and then come back after you're done, and we can talk about it. Now you probably realize number 2 on this one is a little bit tricky. We're not going 10 times 10 times 10 times 10. So if you've got 10,000 on this one, then we got that wrong. And the big reason on this is that it says 4 different digits. In other words, I have 10 options for number 1, but number 2 I don't, because this one has to be different than this one. So instead of 10, like if I use the number 4 on this one, I cannot use the number 4 here, here, or here, because they have to be different digits. So this one's just a little bit tricky there, so you really have to pay attention to how it's worded. And that'll conclude this lesson. You can rewatch the video if you'd like, or I do have other videos of specific problems that you can go through if that makes it any easier for you.